Constellations of stars, mirrors on city walls. I don't see nobody but you. You're my face, you're my muse, you're a 19th floor view. I don't see nobody but you. Constellations of stars, mirrors on city walls. I don't see nobody but you. You're my face, you're my muse, you're a 19th floor view. I don't see nobody but you. Constellations of stars, mirrors on city walls. I don't see nobody but you. You're my face, you're my muse, you're a 19th floor view. I don't see nobody but
Mixture of baby powder and distilled water. 2 drops of baby powder and 2 ml of distilled water. Within 30 seconds of our observation of the mixture, it seems like the baby powder did not dissolve in the water because baby powder, which is typically made from talc or cornstarch, is not water soluble. This means it doesn't break down when mixed with water. We can still see grains of baby powder, suggest that the particles are simply suspended in the water, rather than being dissolved. This is consistent with the characteristic of non-water soluble substances. The particles of the baby powder are likely sinking to the bottom, rather than being absorbed or dissolved. It also lacks of smell due to the fact that baby powder is often lightly scented or unscented, and when mixed with water, any slight fragrance have been diluted. The white color of the mixture is probably due to the original color of the baby powder. Since it didn't dissolve, the color stayed at the same. After 1 minute, it appears that the baby powder, which is not water soluble, has settled at the bottom of the beaker after being mixed with the distilled water. When you first mix the baby powder with the water, it likely forms a suspension, with the powder particles temporarily disappeared in the water. These undissolved particles have settled at the bottom of the beaker. The water above the settled baby powder becoming clearer is a result of this settling process. As the undissolved baby powder particles sink to the bottom, they leave behind clear water. This is because the particles that were clouding the water have now settled out of the mixture.
2 drops of baby powder and 2 ml of ethanol. Within 30 seconds of our observation, the mixtures, it is seems like the baby powder also did not dissolve in the ethanol within 30 seconds. We can still see a grains of baby powder and indicates that the particles are suspended in the ethanol rather than being dissolved. This is a common characteristic of insoluble substance when mixed with a liquid. The smell of the ethanol dominates the mixtures. Ethanol has a distinctive pungent smell. The color of the mixtures of the baby powder and ethanol would likely remains the same as the original color of the baby powder, which is typically white. This is because baby powder does not dissolve in ethanol, so it would change color. The baby powder particles would sink to the bottom, but they would dissolve or change color. After 1 minute, it appears that the baby powders has sunk to the bottom of the beaker, while the layer above is consists of ethanol. This indicates that the baby powder is denser than ethanol, causing is to settle at the bottom. The baby powder is not dissolved in ethanol. It have a very strong smell that is coming from the ethanol, which is quite potent.
2 drops of baby powder and 2 ml of diluted HCl. Number 1. Within 30 seconds of our observation of the mixture of baby powder and diluted HCl, it appears that the baby powder has undergone a partial dissolution. HCl is an acid that can react with the certain components of the baby powder, such as starch or cornstarch, causing them to break down to some extent. This partial dissolution may result in a change in the texture or consistency of the baby powder, making it appear semi-dissolved. We can still smell the baby powder, suggest that some of its fragrance or skin compounds have been released into the mixture. This could be due to the reaction between the diluted HCl and the baby powder, which may have caused the release of volatile compounds responsible for the skin. After 1 minute, it appears that the diluted HCl has absorbed the baby powder. This absorption could be due to the reaction between the diluted HCl and the components of the baby powder. The diluted HCl break down the talc or cornstarch particles in the baby powder, causing them to dissolve or form new compounds, resulting in changes in the texture, consistency, and color of the mixture. We can still smell the baby powder. This could be because the scant compounds of the baby powder are released during the reaction with the diluted HCl. These compounds may be more volatile and noticeable compared to the odor of the diluted HCl.
Based on our observation of the experiment with Rush Snowbird candy and water within 30 seconds, it appears that the Rush candy absorbed the water. The absorption of water by the Rush candy is due to its composition and structure. The Rush Snowbird candy contains various ingredients such as sugar and flavoring that are capable of absorbing water molecules. As a result, the candy particles swell and take in the surrounding water. The stickiness that we observe in the water could be attributed to the dissolved sugar and other components from the Rush candy. When this substance dissolves in the water, it creates a sticky or syrup texture. The presence of the menthol or cool scents from the Rush Snowbird candy suggests that the flavoring or fragrance compound in the candy are released into the water. These compounds are volatile and can be detected by our sense of smell. Despite the absorption of the candy and the presence of its scents, it's interesting to note that the water remained transparent. This indicates that the dissolved components of the candy did not significantly affect the transparency of the water. Based on our observation of the experiment after 1 minute, It appeared that the rush snowball candy is slowly dissolving in the water. As the candy melts, the water becomes sticky because the sugar and the other ingredients in the candy are dissolving in the water. This creates a sticky solution or syrup-like consistency in the water. We can smell the menthol or coolness of the rush snowball candy. Indicates that the candy flavor and scent compounds are being released into the water and the water remains transparent.
Snowball and 2 ml of ethanol. Based on our observation on a crushed snowball candy and ethanol mixture within 30 seconds, it appears that the snowball candy is not dissolving in the ethanol. This could be due to the fact that the candy contains ingredients that are not soluble in ethanol. Instead of dissolving the snowball candy, it hardening in the ethanol. This could be because the ethanol is causing the sugar and other components of the candy to crystallize, leading to a hardened mixture. The fact that the ethanol becomes clearer suggests that it is not significantly interacting with the candy. Ethanol is a clear liquid, and if it doesn't dissolve or react with the candy, it would remain transparent. Based on our observation of a crushed snowball and candy and ethanol mixture after 1 minute, it appears that the ethanol is being absorbed by the crushed snowball candy. Ethanol, being a solvent, has the ability to dissolve certain substances, including the ingredients present in the snowball candy. As the candy absorbs the ethanol, it undergoes a process of dissolution, where the candy particles break down and mix with the solvent. The strong smell of ethanol has a distinct odor, and as it is absorbed by the candy, the aroma of ethanol becomes more pronounced.
Snowball and 2 ml of diluted HCl. Based on our observation of the mixture of crushed snowball candy and diluted HCl within 30 seconds, it appears that some interesting changes have occurred. The crushed snowball candy becoming hardened could be due to a reaction between the candy's ingredients and the acidic nature of the diluted HCl. This reaction may cause the candy to undergo a chemical change, resulting in a harder texture. On the other hand, the snowball candy slowly melting suggests that some of its components are being dissolved by the diluted HCl. The acid in the HCl can break down certain ingredients in the candy, causing it to liquefy or melt. We can also smell the cooling effect of the menthol in the crushed snowball candy. Based on our observation of the mixture of the crushed snowball candy and 2 ml diluted HCl after 1 minute, it appears that the crushed snowball candy is undergoing a reaction with the acid. The presence of HCl, which is an acid, can cause a chemical reaction with the candy. The acid reacts with the ingredients in the candy, causing it to break down and dissolve. As a result, the crushed snowball candy becomes smaller and starts to melt. The smell of menthol that we perceive is likely due to the release of menthol compounds from the candy during the reaction. As the candy dissolves and reacts with the acid, the menthol compounds are released, leading to the familiar menthol scent. Mixture of paracetamol and 2 ml of distilled water. Based on our observation of the mixture of paracetamol and 2 ml of distilled water within 30 seconds, it appears that the paracetamol did not fully dissolve in the water and form a lump instead. The fact that the paracetamol formed a lump suggests that it is not readily soluble in water. It may require more time or agitation to fully dissolve. The lump formation could be due to the paracetamol particles clumping together but not dispersing evenly throughout the water. There was no smell and the mixture did not mix. This could indicate that paracetamol itself does not have a strong odor and that it does not readily mix with water without additional time or stirring. After 1 minute, based on our observation of the mixture of paracetamol and 2 2 ml of distilled water, it appears that the water has absorbed the paracetamol.
Paracetamol and 2 ml of ethanol. Based on our observation of the mixture of paracetamol and ethanol within 30 seconds, it appears that the paracetamol has mixed with the ethanol, resulting in the strong smell of ethanol and a dirty white color. The dirty white color could be a result of paracetamol particles dispersing in the ethanol. It's possible that the paracetamol may not completely dissolve, leading to a cloudy or murky appearance in the mixture. Based on our observation of the mixture of paracetamol and ethanol after 1 minute, it appears that the paracetamol has mixed with ethanol, resulting in a strong smell of ethanol and a color resembling coconut vinegar. When paracetamol, which is a solid medication, is mixed with ethanol, it can dissolve to some extent due to the solvent particles of ethanol. This dissolution allows the paracetamol particles to disperse and mix with ethanol. Paracetamol and 2 ml of diluted HCl. Based on our observation, the mixture of paracetamol and diluted HCl within 30 seconds, it appears that the mixture has formed bubbles and has a lumpy consistency. Additionally, the paracetamol and diluted HCl did not mix well. The formation of bubbles suggests of a chemical reaction may be occurring between the paracetamol and the diluted HCl. This reaction could result in the release of gas, leading to the formation of bubbles within the mixture. The lumpy consistency indicates that the paracetamol and diluted HCl did not dissolve and mix together smoothly. This could be due to the specific particles of the paracetamol or the reaction between the ingredients. Based on our observation of the mixture of paracetamol and diluted HCl after 1 minute, it appears that the reaction is occurring between the two substances. The presence of bubbles suggests that a chemical reaction is taking place. When HCl reacts with paracetamol, it can release carbon dioxide gas, which can manifest as bubbles in the mixture. The formation of the bubbles indicates that a reaction of a generating gas by a byproduct. The smell resembling medicine in the hospital could be attributed to the reaction between the acid and the paracetamol. As the reaction occurs, it may be released certain compounds that are reminiscent of medical scents often associated with healthcare settings. The presence of small grains of paracetamol suggests that the reaction may not have fully dissolved and reacted with all of the paracetamol particles. This could be due to the factors such as insufficient stirring or the specific properties of the paracetamol and the acid.
Constellations of stars, mirrors on city walls. I don't see nobody but you. You're my vice, you're my muse. You're a 19th floor view. I don't see nobody but you. Constellations of stars, mirrors on city walls. I don't see nobody but you. You're my vice, you're my muse. You're a 19th floor view. I don't see nobody but you. Constellations of stars, mirrors on city walls. I don't see nobody but you. You're my vice, you're my muse. You're a 19th